Hello students. In the last class, we started the new chapter, Spectra. We completed the first topic, dispersion of light also. You saw that when white light was passed through a glass prism, it was splitted into a group of 7 colors. This is known as dispersion of light. Today, we are moving on to the next topic of this chapter, the electromagnetic spectrum. Electromagnetic spectrum is the complete group of electromagnetic waves. You are familiar with some of the electromagnetic waves such as X-ray, visible light, microwave, radio wave, etc. You are going to learn about these electromagnetic waves in detail later. Now, you can listen to the history of electromagnetic spectrum. Discovering the electromagnetic spectrum. In the year 1800, Sir William Herschel was examining the spectrum of light from the sun. He was an astronomer, German by birth, but working at Slough near London. He knew that the sun was a star and wondered what he might find out about the sun by looking at his spectrum. He was also exploring the question of how much heat was contained by the different colors of visible light. He devised an experiment where he used a glass prism to separate sunlight into its rainbow of colors. Then he placed a thermometer under each color, with one extra thermometer just beyond the red light of spectrum. Herschel noticed an interesting effect. The thermometer reading grew higher as he moved towards the red end of the spectrum. What would happen if he moved just beyond the end? To his surprise, he found that the thermometer that was seemingly out of the light had the highest temperature. There was nothing to be seen beyond the red, but there was definitely something there. Thus, Sir William Herschel discovered that it was infrared light. This is the portrait of Sir William Herschel pictured with the experiment that enabled him to discover infrared light. This discovery of radiation beyond the red end of the spectrum encouraged people to look beyond the white light. In 1801, Johann Wilhelm Ritter, a German scientist, was inspired by Herschel's discovery to see if there might be light just beyond the purple end of the spectrum. He used silver chloride to look for invisible rays. Silver salts are blackened by exposure to the sunlight. So, he directed a spectrum of sunlight onto paper soaked in silver chloride solution. The paper became blackened, and to his surprise, the effect was strongest beyond the violet end of the visible spectrum. He had discovered another extension of the spectrum which came to be called ultraviolet radiation. In 1867, James Clerk Maxwell, a Scottish physicist, eventually showed that light was produced by small oscillations in electric and magnetic field, or light is an electromagnetic wave. His theory allowed him to predict that there should be light with even longer wavelengths than infrared light. By the early years of 20th century, physicists had discovered or artificially produced several other types of electromagnetic wave to complete the electromagnetic spectrum. This is the story of electromagnetic spectrum. Now let us learn more about electromagnetic spectrum and its properties. Electromagnetic spectrum. The full range of electromagnetic waves is called the electromagnetic spectrum. The range of wavelengths of electromagnetic spectrum is huge. The electromagnetic spectrum consists of the following electromagnetic waves: radio waves, microwaves, infrared, visible light, ultraviolet rays, X-rays, and finally gamma rays. At one end of the spectrum is the radio wave, which has a wavelength of several kilometers. At the other end are the shortest gamma rays with wavelengths of less than 1 billionth of a millimeter. Students, do you know from where does the electromagnetic waves come? You have learned about the atomic structure, isn't it? In an atom, the electrons have negative charge and the nucleus has positive charge. Electromagnetic waves are emitted whenever the charged particles like electron and proton oscillate. That is, when they vibrate or when they lose their energy. For example, you know that every matter is made up of atoms. So, the filament of a bulb also contains atoms. These vibrating atoms in a hot, glowing filament emit infrared radiations and light. Similarly, an oscillating electric current also emits radio waves. Electromagnetic waves have some properties similar to that of light waves and sound waves, which you have already studied in the previous chapter. Let's check what are the properties of electromagnetic waves. First property is that they all are transverse waves, which means their oscillations are right angles to the direction of travel. An electromagnetic wave consists of both electric field and magnetic field. So, here it is the electric field and magnetic field that are oscillating and not the material. The vector E in the figure denotes electric field and the vector B is the magnetic field. Both of them are vibrating perpendicular to each other as well as to the direction of travel. Next, it is the speed of electromagnetic waves. All the electromagnetic waves can travel through vacuum and they all have the same speed in a vacuum. They travel with a speed of 3 into 10 raised to 8 meter per second through the vacuum, which is the speed of light. Like light, the speed of other electromagnetic waves also depends on the material through which they are traveling. Various studies show that they travel fastest through a vacuum. Coming to the next property, wavelength and frequency. All the electromagnetic waves have different range of wavelength and frequency. Radio waves have longest wavelength and shorter frequency, whereas gamma rays have shorter wavelength and greater frequency. From the diagram, you can find that going from left to right, there is increase in the wavelength, and from right to left, there is increase in frequency. Visible light, that is sunlight, is also a part of the spectrum, in that red light has a greater wavelength than violet, and violet has a greater frequency. Visible light is having a frequency over 10 raised to 14 Hz. So, these are the properties of electromagnetic waves. In this part, we discussed about the generation and properties of electromagnetic waves. In the next video, we will be learning about the uses of each electromagnetic waves. Thank you.